Our sun, the heart of our solar system, is a source of life-giving light and warmth. However, it also unleashes a constant stream of energy and particles into space, a phenomenon we call space weather. This celestial weather can have profound effects on our planet, impacting everything from our power grids to our communication systems. Understanding and predicting space weather is crucial to safeguarding our technological infrastructure. That's where the Space Weather Prediction Center, or SWPC, comes in. The SWPC serves as our vigilant guardian, constantly monitoring the sun and forecasting potential space weather events. Nestled in the foothills of the Rocky Mountains in Boulder, Colorado, the SWPC stands as a sentinel of space weather. As a division of the National Weather Service and part of the National Oceanic and Atmospheric Administration, or NOAA, the SWPC plays a critical role in national security and disaster preparedness. The SWPC's mission is clear: to monitor, analyze, and forecast space weather disturbances. They provide timely and accurate warnings to government agencies, private industries, and the public, enabling us to prepare for and mitigate the effects of space weather. Space weather refers to the ever-changing environmental conditions in space, driven by the sun's activity. This includes a range of phenomena, such as solar flares, coronal mass ejections, or CMEs, and geomagnetic storms. Solar flares are sudden, intense bursts of radiation from the sun's surface, while CMEs are massive eruptions of solar material and magnetic fields into space. When these solar storms reach Earth, they interact with our planet's magnetic field, causing geomagnetic storms. These storms can disrupt our technological systems, leading to power outages, communication blackouts, and GPS navigation errors. To keep a watchful eye on the sun and track space weather events, the SWPC relies on a sophisticated network of spacecraft and ground-based observatories. Satellites, such as the Solar Dynamics Observatory, or SDO, and the Geostationary Operational Environmental Satellites, or GOES, provide a continuous stream of data from their vantage points in space. These spacecraft observe the sun in various wavelengths, allowing scientists to monitor solar activity and track the progress of solar storms. On Earth, a global network of ground-based observatories complements these space-based observations. Section 5. Space weather's impact on Earth. The impacts of space weather on our planet can be far-reaching, affecting various aspects of our technological infrastructure. One of the most significant concerns is the potential disruption of power grids. Geomagnetic storms can induce currents in long conductors, such as power lines, leading to voltage fluctuations and even blackouts. In 1989, a severe geomagnetic storm caused a widespread power outage in Quebec, Canada, leaving millions of people in the dark. Space weather can also interfere with radio communications, particularly high-frequency radio waves used for aviation and maritime communication. Section 6. Echoes of Space Weather Past. History is replete with examples of significant space weather events that have impacted our planet. These events, often driven by solar activity, have had profound effects on both technology and society. From the early days of telegraph systems to the modern era of satellite communications, space weather has left its mark. One notable event occurred in 1859, known as the Carrington event, the largest geomagnetic storm ever recorded. This massive solar storm was named after British astronomer Richard Carrington, who first observed the solar flare that caused it. The storm was so powerful that it created auroras visible as far south as the Caribbean. The storm caused telegraph systems worldwide to fail, with some operators reporting electric shocks and fires. Telegraph lines sparked and paper caught fire, illustrating the immense power of the geomagnetic storm. This event highlighted the vulnerability of early electrical systems to space weather. In more recent times, in 2003, the Halloween storms, a series of intense solar flares and CMEs, disrupted satellite communications, caused widespread radio blackouts, and even forced some airlines to reroute flights. These storms demonstrated that even with advanced technology, we are still susceptible to the whims of space weather. These past events serve as stark reminders of the potential consequences of severe space weather. As our reliance on technology grows, understanding and preparing for space weather becomes increasingly important. scientists continue to study these phenomena to better predict and mitigate their impacts, ensuring that we are better prepared for the next major space weather event. Section 7. Predicting the unpredictable. In this section, we delve into the fascinating and often daunting task of predicting space weather. Just as meteorologists forecast the weather on Earth, scientists at the Space Weather Prediction Center, or SWPC, strive to predict the behavior of the sun and its effects on our planet. Predicting space weather is a complex and challenging task, akin to forecasting the weather on Earth but on a much grander scale. The sun, with its immense power and influence, can unleash solar flares and coronal mass ejections that travel across the solar system, impacting planets, satellites, and even astronauts in space. The SWPC employs a combination of sophisticated computer models and human expertise to forecast space weather events. These models are designed to simulate the sun's activity and predict how solar storms will interact with Earth's magnetic field. These models take into account various factors, such as the sun's current activity, including sunspots, solar flares, and coronal mass ejections. By analyzing these elements, scientists can better understand the potential for space weather events. The orientation of solar storms is another critical factor. Depending on their direction and intensity, these storms can have varying effects on Earth's magnetosphere, which acts as a protective shield against solar radiation. The Earth's magnetic field itself is a crucial component in space weather prediction. By monitoring changes in the magnetic field, scientists can anticipate how solar storms will interact with it and what potential impacts may arise. The SWPC issues space weather alerts, warnings, and watches similar to weather forecasts to inform the public and relevant stakeholders about potential impacts. These alerts are essential for preparing and protecting our technology and infrastructure. To inform the public and relevant stakeholders about potential impacts, these alerts are disseminated through various channels, including websites, social media, and direct notifications to ensure timely and widespread communication. These alerts provide advance notice, allowing time for mitigation measures to be implemented. Engineers and technicians can take steps to protect satellites, power grids, and other critical infrastructure from the potentially harmful effects of space weather events. By staying informed and prepared, we can minimize the risks and ensure the continued functionality of our technological systems. Section 8. Shielding our technological heartbeat. As our reliance on technology grows, so too does our vulnerability to space weather. Protecting our critical infrastructure from the potential impacts of space weather is paramount. One approach is to harden power grids and other vital systems against geomagnetically induced currents. This can involve installing protective devices such as capacitors and surge protectors to divert excess currents and prevent damage. Another strategy is to develop backup systems and contingency plans to ensure continuity of operations in the event of space weather disruptions. Section 9. Conclusion. A universe of collaboration. Space weather is a global phenomenon that knows no borders. It affects every corner of our planet, from the poles to the equator, influencing not just our technology, but also our daily lives. The sun's activity, such as solar flares and coronal mass ejections, can disrupt communication systems, navigation, and even power grids. Understanding and predicting these events is crucial for minimizing their impact. International collaboration is essential for effective space weather forecasting and mitigation. Scientists from different countries bring unique perspectives and expertise, enriching the collective knowledge base. By working together, they can develop more accurate models and share critical data in real time, ensuring that everyone benefits from the latest advancements in space weather science. The SWPC works closely with its counterparts around the world, sharing data, expertise, and resources. This collaboration extends to various international space agencies, research institutions, and universities. By pooling their resources, they can maintain a constant vigil on space weather, providing timely warnings and actionable insights to governments, industries, and the public. This global cooperation enhances our understanding of space weather and improves our ability to predict and prepare for its effects. Satellites orbiting Earth play a crucial role in monitoring solar activity and gathering data. These satellites form a global network, providing a comprehensive view of space weather events as they unfold. The data collected is then analyzed and used to refine predictive models, making forecasts more reliable. As we venture further into the cosmos, space weather awareness and preparedness will become even more critical. Missions to the Moon, Mars, and beyond will rely heavily on accurate space weather forecasts, to ensure the safety of astronauts and the success of the missions. Understanding the space environment is not just about protecting our technology on Earth, but also about enabling humanity's future in space. The SWPC, along with its international partners, will continue to play a vital role in safeguarding our technological civilization from the vagaries of the sun's activity. By advancing our knowledge and improving our predictive capabilities, they help ensure that we are better prepared for whatever the sun throws our way. This ongoing collaboration is a testament to what we can achieve when we work together, transcending borders and uniting for a common cause.